Welcome to video 11. In this video, we're going to use what we learned in video 10 about data trees, and we're going to arrange the points we have on these surfaces into different branches. Each branch will have 4 points in it, which will be the 4 corner points for our squares, and then we'll use those 4 corner points to make polylines in the shape of squares. So we just did a review of branches. We could also do a quick overview of polylines. A polyline in Grasshopper is kind of like a list of points, very much like a list of points. The main noticeable difference is that in the Rhino viewport, you'll see a line drawn from point 0 to point 1 to point 2 and so on. So we'll go over this too quickly also, but honestly there's not much to go over. All we need to do is just give the polyline component a list of points, and it will connect the dots between those points in whatever order they come in. So I think that's going to be pretty easy when we get to it. So jumping back in where we left off, remember this point down on the left is point 0, and over on the right this point is at index 13, and so these here are 14 and 15 and 16 and so on. And what we want to do is make a polyline between index 0, index 1, index 15, and index 14. So we need to somehow make a component that holds those 4 integers, 0, 1, 15, and 14 in that order. So beyond that, we don't just need a component that holds 0, 1, 15, and 14. We need that to be in one branch, and then in the next branch we want 1, 2, 16, and 15, and then in the next branch we want 2, 3, 17, and 16, and so on. And we want to do that until we get to the end, the very last point. Right now there are 42 values, and so the last point is gonna be index 41. So the way to do that is, first let's get our rows, hide this wire, bring that over there, and our columns plus 1. I'll hide that wire and bring this next to the rows. And let's multiply these two numbers together. So that's 28. Now, and that is what we want, even though there are 42. Again, if I hover over this, we can see there are 42 different points. 14 times 3 is 42. 14 times 2 is 28. For now, we only need 2 rows at a time. We need all of the indices for the bottom row and all of the indices for the middle row for our 0 and 1 items and our 1 and 2 and so on, because those are all going to be the bottom edges of the squares, and then we do need the second row to get this top square. So right now we do need 28, and then when we do the top edges of the square, we'll also need 28, but we'll need to start at index 14. And so I'm going to make a series that counts from 0 to 28, or 0 to 27 actually. So series, go up 28, or do that 28 times, and we have a list from 0 to 27, and 27 is going to be this last index here. And then if I get another series component and use all of these numbers as our start points, and I count 2 each time, because each time I need 0, 1, and then I need 1, 2, and then 2, 3, then what we get out is just what we needed. I'm going to simplify this. So in branch 0 we have 0, 1, in branch 1 we have 1, 2, and so on, 2, 3, all the way up to 27, 28. And we'll deal with this last one later. We don't need 28 actually. This is 27, this is 28, but we'll get to that in a bit. So that's good for our bottom edges of our squares. And then for the top edges, I also want to count up 28 times. But I don't want to start at 0, I want to start at the length of this list plus 1, which will actually just be the length of this list. So if this is index 13, I want to start at 14. Or actually, I want to start at 15, because we're going to go, instead of 14, 15, we're going to go 15, 14. So the first item should be 15. So I'm going to get an addition, and then 1, I'll plug that in, so this is 14, plus 1, output should be 15. And now we have a list from 15 to 42. And again, these are going to be our starts for the next series. So I can copy this and those are going to be our start points. But instead of adding 1 each time, I will subtract 1. So //-1, and that's going to go into our step. And so what does this look like? We start at 15 and go to 14, then 16, 15, 17, 16, and so on, all the way to 41, 42, or 42, 41. And then let's merge these two together with these numbers coming first and then these indices coming second. You get rid of that, and let's look at the output. So now I have 0, 1, 15, 14, and that's what we wanted. This is 0, 1, 15, 14. So now we can organize this a little bit. I don't need this. I'll call this group top indices, and this one will be group bottom indices. And then together they can be organized indices like mesh. Okay. And these are going to be the indices that we use to create polylines according to this list of points. So I'll bring this down here. These are our points, and let's get a list item. These are the list items. These are all the indices, and this is the list. And if we get a polyline component and plug these points that are organized now according to these indices, then we see all of our squares, but we see some extra, right? So every time we get to the end, it's still connecting with the next one on the list. And so we need to call these crossovers that are spanning the entire surface. So first, let's put all of these polylines in a curve component, and we can call it all polylines, and we'll hide all of this. And let's see which polylines are crossing the entire surface. With a list item, this is our list of polylines, and we need to flatten it because let's look and see how these are organized. Because we started with branches of grouped indices, and now so each polyline has its own branch. If I click flatten, then we just have one list of polylines. And let's get a counter between 0 and 42. So that's the first one. If we go up to item 13, so we have 12 columns here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, we have 13, sorry. And so index 13, since this is column 1, or since this is polyline 0, then index 13 is going to be our 14th polyline. So every time we get to the 14th, it's going to cross, because that's the number of columns we have plus 1. So we have 13 columns plus 1, and 14 is going to cross. And again, this is index 41, so it's actually the 42nd one in the list. So we have 14, and this should be 27. So 13, 27, and 41, which is actually the 14th, the 28th, and the 42nd. And so it's good that we can find a pattern like that, because that's just 14 times 1, 14 times 2, and 14 times 3. And 14 is 1 plus the number of columns that we have. And we have a component that is 1 plus the number of columns that we have right here. So let's copy this and bring this over here, because that's going to be important. Let's just put this up here for now. And let's make a series that gives us the indices of all of these polylines. And so if we get a series component and we get a list length component, this is going to tell us how many polylines we have. There are 28. So if we just plug this into the series component, that will give us the indices for each one. But instead of the indices, we actually want to know the number if we were actually counting from 1 for each of these squares. And so right now this square here has an indice of 0, but we would rather know that that's the first one and that's the second and so on, because after the 13th, it's the 14th that we need to concentrate on, and then it's the 28th, and then it's the 42nd. So instead of starting at 0, let's start at 1. Actually, yeah, there is no 42nd, so we're only going to 28. So we just need to get rid of the 14th and the 28th, but if this were higher, let's make this surface a little bit higher so we have more than just 2 here. And this is the referenced surface, so we have that here, make reference surface. Let's increase the height a little bit. Now we have 3. So yeah, index 41 is another one that we want to get rid of, and that's going to be the 42nd item in the list. And this series is going from 1 to 42. So now I'm going to use a component that is really common in coding. It's called modulus. And so what this does is it takes a number. Let's get a slider between 0 and 9 or 10. So I'll just type in 10. Let's get 2 of these actually and see what the output is. I'm going to divide. So what this is doing is actually dividing the first number by the second number, so 10 divided by 10. And what this gives you is the remainder. So obviously 10 divided by 10 is not 0, but 10 divided by 9 will have a remainder of 1. 10 divided by 8 is a remainder of 2. And if I get down to something that is evenly divisible, such as 5, the remainder is going to be 0. So every time there's no remainder, this will give you a 0. So let's get rid of these and get rid of this. And we want to divide our nth items, so 1 through 42, by our columns plus 1. So this is 14 right now because it's the 14th item each time that we need to get rid of. So multiples of 14 we need to get rid of. So every time that this number is evenly divisible without a remainder by 14, then we need to get rid of that. And so some of these are going to have a remainder of 0, and those are the ones that we need to call. So if we get up to the 13th item, the 13th index here, which is actually the 14th item, we have a remainder of 0. So let's get an equivalency or an equality component and see where this modulus is equal to 0. So now this is giving us a pattern of true and false. We can see again index 13 is true. If we go down to the bottom, the last one, index 41 is true. So let's grab those indices and we're going to use a member index component. And this takes in a set. And so our set is these true and false values. And it's going to check and see which indices equal whatever you put in here. And so I'm going to get a Boolean toggle and set it to true. So it seems like maybe we could have used this over here and just said which items from here are equal to 0, but I've found in the past that this component works better if you only use true and false. And so I usually first do an inequality to get a true-false pattern. And instead of just looking for the items that are equal to 0 here, I get the items that are equal to true here. So let's see what's coming out here. This should be a list of indices. And so 13, 27, and 41, those are the squares that we wanted to get rid of because they cross the entire span. So let's delete that and let's get a call index component. And these are the indices and all polylines. This is our list. I'm going to get another curve component here. And I'm going to copy this and call this all polylines also. I'll hide these. And so if I hide this and these, now we only have the squares that we want. So let's go back quick and see how this works on the circle, since the circle is one that wraps around. So I'm going to plug in the circle here, and we have all of our squares. But so this works, and this it's getting rid of the ones that we don't want, and we wouldn't have actually been able to see the ones that we don't want on the circle. So I'm going to hide this for now and just show the all polylines. It looks like we only have the polylines that we want here. But in fact, if we go over here and show this, we see that we do have some polylines that we don't want. So instead of crossing the entire span, these are just vertical polylines. It's the equivalent of crossing the entire span on an unclosed surface, but when it's closed, it just jumps up to the next level. And we do want to call these eventually, but for now, they're actually going to be beneficial when we're applying the pattern, because the pattern is repeating. It's going 0, 1, 0, 1, and it's repeating this way, 0, 1, 0, and so on. And keeping these for now, when the surface is closed, is actually going to be helpful when we're applying that. So this is where our wrap Boolean component comes in again, and another opportunity to use the stream filter component. So I'm going to delete this for now. And now we have two sets of polylines. We have the ones that we want to use for the circle and the triangle, the ones that are closed, and we have the ones that we want to use for the open surfaces. So I'm going to get a stream filter, and I'm also going to pull both of these out. So curve, because I don't know, we might need this later. And I'll call this poly pulled crossovers, and this will just call all polylines. So I have them both here, and in order to choose depending on whether or not it's a closed surface, I'll put the called ones into stream 0 or into gate 0, and I'll put all polylines into gate 1, and I'll hide these and hide these. And then I need the wrap Boolean component, which is way back here. I'll plug that in there and bring it all the way across, and that's going to tell us whether or not we should choose, or which gate to choose, 0 or 1. When this is wrapped, we want it to choose all polylines. When this is not wrapped, we want it false will equal 0, and we want it to choose the called polylines. Okay, I'm going to clean this up a little bit. First, I'm going to put these in a component, curve component, and I'll call these polylines dependent, because these depend on whether or not it's a closed or open surface. I'll hide this. So I don't think I'll need this again, the all polylines, so I'm going to delete that for now, but we will need this, the called crossovers, and we'll need wrap, so I'll bring this out and make that default. And one more thing that we'll need is this list of indices, not the ones that we want to call, but the ones that we want to keep. So I'm going to duplicate this, and instead of true, I'm going to set this value to false. And so what's coming out of here is a list of all the indices that we do need, that we do want to keep. And this will come into play a little bit later. I'm going to get an integer, and I'm going to call this indices to keep. And we can organize all of this a little bit better. We'll bring all of this closer to that component and group this and call it get organized points. We'll bring these over here. I'm going to copy this, put that in there, and bring these over here. And we can just make this its own component. So I'm going to copy this and set this wire display to default and plug this in there. And there's one other spot that the polylines are going in here, and that's to this list component here. And so now we just have one input and two outputs. So I'll copy this, and if we select all of these, oops, we do have one more. We have the columns plus 1. So I'll pull this out and set this to default. So now we have two inputs and two outputs. Click the middle button and cluster. And we can call this call crossovers. bring all this over to the left. We can plug this directly into this one. We don't need this intermediate. And so I think these are the 4 things we'll need for the next step, which is going to be make the patterns, these crossing patterns, the cross braces on all of our squares.